Welcome to the Math 8 video for the topic of the distributive property. Okay. Also in this section, we'll be talking about simplifying expressions. So basically covering what was in the last section as well. But we're kind of combining the two here. So this first part is about the distributive property. Should be a little bit of a review. So hopefully most of you have at least heard of the distributive property before. But if not, we are going to review it, look at some examples, see how it works, okay? So what the distributive property tells us is, well, let's first look at the word distributive, okay? Well, what does it mean to distribute something? So like if I distribute papers in class, okay, I'm giving out a paper to every single person in the class, okay? Well, the distributive property works very similarly. That's why we call it the distributive property, because if you have a number, so in this case we're using variables here just to indicate any number, okay? So if we have a number A and we multiply it times two terms added together in here, so B plus C, so once again a number plus another number, then what we can do is we can take a shortcut, okay? Well, not really a shortcut, but what we can do, instead of writing this with the parentheses, we can take the A, so we take the A and we distribute it to both terms on the inside of the parentheses, okay? So what that means is we take A and we multiply it times B. So we take A times B, okay? Well then, since there's plus in the middle here, we're going to add to it A times C. So essentially what we've done here is we've taken A and we've given B an A, so multiplying B times A, and then we multiplied C times A, okay? So basically the way it works is we take A and we give it to each one of the other terms, so A times B plus A times C. This also works with subtraction, so if there's subtraction in here, you have two terms being subtracted, in this case B minus C, it works exactly the same. We take the A, which is on the outside of the parentheses, and we distribute it to the B and the C, okay? So once again, we're going to have A times B minus, in this case, since there's minus in here, A times C. And that's really all there is to the distributive property, okay? Now, a lot of people will be confused here, maybe by looking at this with just a bunch of variables, okay? So let's look at some actual examples where we combine numbers and variables so you can see it in action with some numbers, okay? So the first four here are going to be guided examples, so I'm going to work them through with you. You'll write them down on your paper there or on the computer screen there, however you're doing this. So I'll work through these, and then the next 15, and I'll make a stop at the end of the fourth example here. What I would do is pause the video after these guided examples and try the next 15 questions on your own, and then refer back to the video to make sure if you did all these questions correctly. So guided example number 1. Well, we see the distributive property is necessary here because we have 4 times, and then we have x plus 9. So you can think of x as being in the place of b here, 9 being in the place of c, and 4 is the a. So what we're going to do is we're going to take this 4, since it's times this in parentheses, we're going to take 4 and we're going to give 4 to each term on the inside. So 4 times x plus 4 times 9. So when we do a little simplification here, 4 times x, we can just write that as 4x. 4 times 9, if you need to double check yourself on a calculator, I don't mind. 4 times 9, though, if you know your times tables, is 36. And that's actually the final answer. That's as far as we can go. Because from last section, we know, well, this has a term, this is a variable term, this is a constant term. We can't add variable terms and constant terms, okay? So it just has to stay 4x plus 36. Same thing happens here with number 2. We have 7 times, in parentheses, k minus 3. So we can take the 7 on the outside and distribute it to, every term on the inside. So 7 times k minus 7 times 3. So what we end up here with is 7 times k. Well, we can just rewrite that as 7k minus 7 times 3. Once again, times tables coming in handy. That's 21. And then the same reasoning as got example number 1 there is, well, this is a variable term. 7k is a variable term minus a constant term. We can't simplify that any further, so we end up stopping there. Next two, very similar, except for these two. If you wanted to maybe put a little star by these or something, these have something special that we haven't seen yet, and that's dealing with negative numbers, okay? But it works exactly the same. So what we're going to do is we're going to take this negative 3 and we're going to distribute it to the n and 1 to the 8. So what we end up with here is negative 3 times n. Now do pay attention to what I do with my negatives here. Okay, I am going to put my negatives in parentheses. That's always a good habit to get into, especially if you're going from one line to the next, so you can clearly see what's negative and what's not. And it's actually going to do double duty here, because if we do negative 3 times 8, we're going to have minus, and then it's good to put the negative 3 in parentheses there just to indicate, hey, this is negative 3, so you don't think it's like minus minus for some reason, okay? Once again, that can get a little confusing, so I do strongly suggest, especially with negative numbers, putting them in parentheses. So when we go through and simplify this, we get negative 3 times n. We can just write that as negative 3n minus, well, negative 3 times 8. Once again, times tables coming in. Negative times a positive is a negative. 3 times 8, 24. But now we run into a little bit of an issue, and this is what the star is about here. Negative 3n minus negative 24. Technically, that is correct, but we want the most simplified version, okay? So most everybody would probably agree with me that subtracting a negative isn't very simple, okay? Thinking about subtracting negative numbers, that's kind of a hard thing to think about, okay? So instead of having minus a negative, we can rewrite this as negative 3n. Since we're minusing a negative, that's the same thing as adding the positive. So adding positive 24. And that's actually our final answer here. So negative 3n plus 24. Okay. One way to think about it too, to take a shortcut, and some of you might get this, but if not, do it the exact same way that I've done it here. As you can see, this is a negative. Technically, this term in here is a negative 8. So what we'll end up with is a positive 24, so plus 24. So you can kind of shortcut it there. But like I said, if you're in doubt, you're confused about where this plus 24 came from, break it down like I've done it here. Take each term, negative 3 times n, minus negative 3 times 8, and then actually do all the calculations to get the negatives and positives. And then the only thing you got to worry about here is with this step right here, negative 3n minus negative 24. Well, minusing a negative is the same thing as adding a positive, okay? Now we're going to see the same thing here with number 4. Here we're going to take the negative 2, and we're going to distribute it to the 5x and the 2. Now the other thing that's different here is you notice every other example before we just had an n here or a k or an x. Here we've got 5x. But it works the exact same way, because what are we going to do? We're going to take this negative 2 and we're going to multiply it times the 5x, the whole thing, 5x. Then we're going to subtract negative 2 times positive 2, okay? And notice once again, I'm using parentheses when I'm dealing with the negatives here, so I can clearly see what should be negative, what should be positive, okay? So now we've got negative 2 times 5. Well, negative 2 times a positive 5, it's going to be a negative 10. But we still have this x over here, so you can think of it as negative 2 times negative 2 times 5 times x. Well, then that's going to be negative 10 times x. Okay? So basically what you do is you multiply the term here by, or the negative 2 by the coefficient on the x here, so that's 5. So negative 2 times 5 is negative 10. But since it is a coefficient, we have to we can't forget the x. We have to include it. Then we have minus negative 2 times 2. Well, negative times a positive is a negative. 2 times 2 is 4. So, once again, we have the same kind of deal here where we have negative 10x minus negative 4, which technically is correct. That's fine. But to have it in the most simplest form possible, we would take this minus negative 4 and make it plus positive 4. So it's negative 10x plus 4 is our simplified version. And just like the other two examples, and the other three examples, when we get down here, this is a variable term. This is a constant term. This is a variable term. This is a constant term. So we cannot go any further. We can't add variable terms and constant terms together. Okay. Now, once again, this is where I would say pause the video. Go ahead and try the next 15. Okay. See what you get when you simplify each expression by distributing. Like I said, I'm going to go ahead and go work these, but go ahead and pause the video if you'd like to try these on your own just to see if you know what you're doing, okay? See if you can practice a little bit. So with that being said, like I said, pause the video, but I'm going on right now, and we're going to go to the first example in the you try section, okay? So once again, these are ones that you should probably try beforehand, but doing this, we see we got a 7 times, in parentheses, x plus 5. That means we're going to take the 7 and distribute it to the x and distribute it into the 5. So this one's actually pretty easy because we get 7 times x, which is 7 times x, plus 7 times 5. So when we simplify that down further, we got 7 times x, that's just 7x, plus 7 times 5, which is 35. And once again, we're at a spot where we've got a variable term and a constant term. We cannot go any further. So that's actually the final answer for number 1. Number 2, very similar, except for in this case, we're going to distribute a 5. So we take the 5 and give it to the w and give it to the 4. So we're going to end up with 5 times w minus 5 times 4. And here, 5 times w is just 5w minus 5 times 4, which is 20. And once again, that's as simple as we can get it. We've got a variable term and a constant term. We can't subtract those. Okay. Now, number 3, we're running into a little issue here because we have the negative this time. So we distribute the negative. So negative 5 times m is negative 5 times m minus negative 5 times 5. And then once again, we get the little thing happening here where we got a negative times a positive, but first let's take care of this. So negative 5 times m is negative 5m minus negative times a positive is a negative 5 times 5, 25. But then, just like number 3 and 4 on the guided practice, we have negative 5m minus negative 25, so we can actually rewrite that as plus 25. So negative 5m plus 25. Number 4, we're going to distribute a 9, but as you see, we got a little weird thing happening in here with the variables in the constant term. They're kind of flipped around. That actually doesn't matter, okay? Because once again, when you distribute, you're giving it to each term. So in this case, 9 times 2 minus 9 times a. And once again, when we simplify that out, 9 times 2 is nothing more than 18 minus 9a. Okay? And that's actually it. You can have a variable on the right-hand side. Now, later on, when we go to solve equations with these kind of expressions, I'll show you some tricks on how to move these things around to make it easier for you to solve an equation like this. But other than that, with this section, all we're looking for is distributing that 9. Okay, so distribute the 9 to the 2, that's 18. 9 to the a, that's 9a. So 18 minus 9a. Okay. Number 5. This one should be super easy because we're distributing a 2 to a y and a 3. So what we end up with here is 2 times y plus 2 times 3. 2 times y is 2y plus 2 times 3 is 6. So 2y plus 6. Number 6, same thing, except we're distributing negative 2. So to both terms here. So we get negative 2. Once again, I like to use parentheses when I'm plugging it in for expression purposes. So negative 2 times x times, or plus negative 2 times 7. So negative 2 times x, that's where we get the negative 2x. Plus negative 2 times 7 is negative 14. And this one is the first time we see, but we've seen this before in this class, is we have plus a minus, or plus a negative here. So once again, kind of like we had when we looked at numbers 3 and 4 on the guided practice, we had minus a negative. Once again, that's not very simple. Okay, in this case, adding a negative is kind of the same. What does it mean when we add a negative? Well, we can rewrite that as negative 2x minus 14. And once again, you can kind of see here, well, negative 2x, negative times a positive should be minus 14. So like I said, if you see this and get better with it, it'll come with practice, okay? So you do have to practice this, but when you go through, it's easy to see what should be positive and what should be negative. But like I said, the simplest version here should be negative 2x minus 14. Number 7, number 7, we're distributing a negative 7. Okay, so the negative 7, so let me move that up, make sure we have enough room here. So we got negative 7, once again I'm using parentheses, times 3 minus negative 7 times 5m. So once again, negative 7 times 3, negative times a positive is a negative. 7 times 3 is 21, so we got negative 21 minus negative 7 times a positive 5, which is negative 35, and then we still have the m over here. Now this one still kind of a little unique because we have the m over here on the right side, but it still works the same as, once again, numbers 3 and 4 in the guided practice. We have the negative 21 up here, but since we're subtracting negative 35, we can write that as plus positive 35. Yeah. So negative 21 plus 35m. And once again, you can kind of see negative times a positive should give you a negative 21. Negative times technically a negative 5 should give you a positive 35. Okay. Number 8, going back to another easy one here. So everything's positive, everything's nice. So we get 3 times 2n plus 3 times 8. So when we simplify that, 3 times 2n is 6n plus 3 times 8, 24. So 6n plus 24. Okay. Number 9, see I'm going a little bit quicker as we go along here because, once again, every single one of these works the same. It's just you got to pay attention and remember how to deal with your negatives. So we got a negative in this case, but everything inside here is positive, so that makes it actually pretty easy. Negative 12 times c plus, since it's plus here, negative 12 times 4. So what we have here is negative 12c plus negative 12 times 4, that is negative 48. And once again, that's technically correct here, but we want it in the most simple form. So instead of adding a negative, we can say negative 12c minus 48. Okay. Same thing with number 10. So let's go even quicker here. So negative 2, going to distribute it to both these positive terms. So in this case, we've got negative 2 times 4k plus negative 2 times 5. So what we end up with is negative times a positive is negative 8k plus negative 2 times 5 is negative 10. And then the same thing happens. We got negative 8k, but instead of plus negative 10, we want to write that as just minus 10. Like I said, that's something you'll get used to the more you do these, okay? It's hard to deal with subtraction and negatives and all that. So just remember, subtracting a positive is the same thing, or adding a positive adding a negative, is the same thing as subtracting the positive. Subtracting a negative is the same thing as adding the positive. Okay, so just remember those two tricks, and that'll help you with your negatives. Now, number 11. Notice here that I've got a little bit of a star action going on here, meaning this is an important example because we look at this and we see negative and then in parentheses k minus 2. Well, just like variables, if there's not a number in front of parentheses, you can actually add in the number 1. So when you just see a negative in front of parentheses like that, technically there's a negative 1 there. So we take the negative 1 and distribute it. So negative 1 times k minus negative 1 times 2. And once again, negative 1 k minus negative, which I don't need those parentheses, negative 1 times 2 is negative 2. We run into the same issue here, okay, minus a negative. And actually, since this is just negative 1k, we can just call this negative k, and then minus a negative 2 is the same thing as plus 2. Now, if you did want to include the 1 here in front of the k, you can do that. But I do want to point out that if you are asked this on some kind of standardized test like the SOL or something, they probably, if you'd have to type it in, they would probably accept the 1 being there. But if it's a multiple choice question, you'll probably see the answer written like this, as just negative k plus 2. Okay, so just know that's kind of another thing to be aware of. If there's no number in front of a variable or in front of parentheses, understandably, there should be the number 1 there. So if you want to go ahead and fill it in, and you could have been doing this the whole time up here, like with the 1 up here, it could be 1c, so it would be negative 12 times 1. Here it's 1k, so negative 1 times 1. Okay, so like I said, dealing with that 1 there, make sure that you do know you are distributing a negative 1, or you can think of it as distributing a negative. So negative k, and then since this is minus 2, it would become plus 2. Okay. Number 12, back to an easy one because we got a positive here, so we distribute that, distribute there. So we get 4 times 1 minus 4 times 7p. So simplify a little bit here. 4 times 1 is 4, minus 4 times 7 is 28, and we can't forget the p. So in this case, 4 minus 28p. All right, and then the last 3 here. Number 13, another what I would consider easy one because we got a positive number here, so we distribute it in a positive. So 9 to the 2r and the 7, so we're going to get 9 times 2r minus 9 times 7. Well, 9 times 2r is going to give us 18r minus 9 times 7. Okay, once again, knowing your times tables come in handy here. It's going to be 63. Okay, but then actually that's as far as we can go. So 18r minus 63. We have another one like we had with number 11. So number 14 here. So if you want to put stars by this one as well, we got negative and then in parentheses 5k plus 4. Technically what's going on here is we have a negative 1 and we're distributing a negative 1. Okay, but if you figured out the shortcut here, all we're doing is making everything negative inside here. So negative 1 times 5k plus negative 1 times 4. So what we end up with here is a negative 5k plus a negative 4. Which, once again, if you figured out the shortcut, that just makes this negative 5k minus 4. Because like I said, it goes in and makes everything negative. So in this case, it makes the 5 negative. Technically, it makes the 4 negative, but once again, we're adding a negative 4. It's the same thing as subtracting a positive 4. And lastly, we have number 15. Notice here I give a little bit more space because we are dealing with fractions. Okay, so I did warn you guys that you would see fractions a little bit more. So in this case, we're distributing. This is just a number. 4/9 is just a number. So we're going to distribute the 4/9 to both 3/8 W, and 10. Okay, so I'm going to go out over here to give myself a little bit more space. That means we're going to have 4/9 times 3/8 W plus 4/9 times 10. Once again, if you know about fractions, okay, if you've looked and figured out how to multiply, add, subtract all those fractions, okay, all we got to do here is multiply fractions. And to multiply fractions, we just multiply straight across. So 4 times 3 is 12. 9 times 8, 72. Oh, 72, not 76. And then the W has to stay there. Plus, well, in this case, we got a special thing where we're multiplying a fraction times a whole number. But as always, we can turn that whole number into a fraction by putting it over 1. So 4 times 10 is 40 over 9 times 1 is 9. And then the very last step we have to do here is technically we would be done here, except this fraction 12 over 72, it can be simplified down to 1/6. So we get 1/6 W plus, we can't simplify 40 over 9, okay? So that's actually our final answer, 1/6 W plus 40 over 9, okay? And once again, dealing with fractions, you got to know how to do it. So notice this is the only one that has it here, but did want to show you one with a fraction because it works the exact same way. We just take the number on the outside and multiply it times the coefficient on the first term, or the coefficient on the variable term, and the constant term in there. Okay, so it's just multiplying by fractions. Now, this next part is a little activity for you. So I'm not going to go through and work every single question out because there is a total, I think, 28 questions on here. Okay, but what you're going to do is, once again, make sure you read the instructions here. So notice I've got it here. Make sure you read the instructions. But the riddle is, why didn't the quarter roll down the hill with the nickel? Okay, so when you fill out your answers, you're going to actually get something here that spells out 4 words. And notice here on this, I've got 4 different rows here, meaning each row is a word. But how this works, once again, if you read the instructions, is you're going to answer every single question. So simplify every single expression on this page, which once again, there's like 28 of them. Okay, some of them are easier, some of them are harder. Because once again, this is going back and looking at combining like terms like we did in the last section. Okay, so some are with distributive property, some are combining like terms. But what you're going to do is in each set, you're going to look and see, okay, for H, you've got 4 times in the parentheses X plus 7. Okay, well, you're going to simplify that using the distributive property and then go over to the next side, so the next ones with the numbers, and you're going to see which one of those 4, in this case for set 1, which one of those 4 expressions equal the same. So basically, you're going to get 2 in each section there that match up. Now, what you do is, for number 1, so when you go down there and you look at the number 1 question, what letter did it match up with? So in this case, number 1 ended up being 6A plus 3 when you simplified it. Well, that matches with letter I, okay, which is 3 times the quantity 2A plus 1. So when you simplify that, you also get 6A plus 3. So what you'll do is put the letter I in for 1. So for example, now, once again, this is a place where I would pause, go work these, see what you can figure out, and then come back here in just a second for the answer. So I'm going to go ahead and answer this, but once again, I would pause, work these out just to get some practice, and just make sure you get the same answer that I do here. So you already knew the first letter was I. The second one, once again, you look at number 2, it's going to match with the letter T. So the first word there is it, okay? Number 3 is going to match with the same one that has the letter H. Number 4 with the same one with letter A. 5 matches with D, so it had. 6 matches with M. 7 matches with O. 8 matches with R. 9 matches with E, so it had more. and then 10 matches with C, 11 matches with E, 12 matches with N, 13 matches with T, and lastly 14 matches with S. So the correct answer here, after you worked all those out, and once again matching them together, you should have that the answer to the riddle is it had more sense. Now, that's not a very funny joke for some of you, but if you catch what that means, well, a quarter has more cents than a nickel. There's 25 cents in a quarter. A nickel has 5 cents. So literally there's more cents in a quarter and a nickel. And then they're playing on the phrase like common sense. Okay. So somebody, if they don't have common sense, they might not do something that somebody who had sense had. Okay. So once again, that's the crux of the joke there. But the whole point here is practice with this. Make sure you get the letter I for 1, T for 2, and so on. And the final answer to the riddle is it had more sense. Okay. Now after that, we're going to run into, so this is a pretty lengthy packet, and this is going to end up being a pretty lengthy video. So the rest of the packet here and the rest of the examples and everything, we start combining the two here. So we start combining in terms of combining like terms like we did last time, and then also what we've just done here with the distributive property. So in this little warm-up section, they're kind of getting you used to doing both of these. So numbers 1 through 4 here, these are ones where it says simplify each expression by combining like terms. So this is like last time, okay, meaning here's 10x minus 6x. Well, once again, if you're clever enough, you can go ahead and see, all right, that's going to be 4x. But what's technically going on here, so what we can do is we can write it as addition, and see, well, what am I going to add? I'm going to add 10 and negative 6. So 10 plus negative 6 gives me 4, and then the x has to go with it. So that's simplified using combining like terms. Number 12, same kind of thing here. We're going to take 12a, and we're going to add to it 4a. Okay, so once again, we can add the variable terms here. So 12a, 4a, and 1a. Okay, so once again, at this point, hopefully everybody's kind of gotten in this way where you can see, okay, well, I've got 12 plus 4 plus 1. 12 plus 4 is 16 plus 1. That should give me 17a. And then the only constant term is negative 8, so it's going to be minus 8. Okay, but once again, if you don't see it that clearly, you can always go back and do the same thing I've always done before, is 12a, and then add the negative 8, then add the 4a, then add the 1a. So we're going to add 12, 4, and 1. That gives us the 17. Those go with a, plus, well, the only thing that's left is negative 8. And then now we've got that same issue we did earlier in the video where we had plus a negative. So we can just rewrite that as 17a minus 8. Okay. So the most simplified version of that is 17a minus 8. Number 3, 5w minus 6 minus 8 plus 7w. Once again, some of you might be clever enough to say 5w plus 7w is going to give me 12w. Minusing 6 and then minusing 8 is the same thing as minusing 14. So the answer is going to be 12w minus 14. But like I said, it doesn't hurt to write this as a sum so you can clearly see what am I adding together here. What are my terms? What are my coefficients? What am I adding together? So I'm going to add 5 and 7, which gives me the 12w. And then negative 6 plus negative 8, negative 14. And then we have the same thing as up here, plus a negative 14, which is the same thing as 12w minus 14. So this is kind of just a little bit of review from a last section, okay? And then the same thing here, negative 7k minus 2k. So again, if you're clever enough, you can see that should be minus or negative 9k, okay? But once again, this is where if you got a lot of negatives and subtraction, write it as a sum. So we got negative 7k plus 17 plus negative 2k plus negative 3. So then we just add the variable terms together. Negative 7 plus negative 2 is negative 9. The k has to go with it. Plus 17 plus negative 3 is 14. Okay. And then once again from there, that's actually as far as we can do it. So we don't have to worry about any negatives over here. So it's just negative 9k plus 14. Same thing with this section, which is just the same kind of stuff we just got done doing all those questions about. Okay, so we want to do this using distributing, so distributing property. So we're going to take the a and distribute it to the x and the 5. So we're going to get 8 times x plus 8 times 5. So 8 times x, that's just 8x plus 8 times 5. Well, once again, times table's coming back. That is 40. And that's actually all there is to it. So you can see the end goal is pretty much the same with each one of these types of questions, is simplify it using combining like terms, simplify it using distributive property. We always end up with something here that's like 8x plus 40 or 2y minus 10 or negative 5y plus 7, okay? And that's the point here, because what we're going to do is when we get these like this, eventually we're going to combine things like this together, okay, as you'll see in the next few examples. But let's finish these out here. So we're going to take the negative 4, distribute it to the 2, and technically the negative 9. So we get negative 4 times 2x minus negative 4 times 9. We get the same kind of thing here. Negative times a positive is negative. 4 times 2 is 8x minus negative 4 times positive 9. We're going to have a negative 4 times 9, 36. And then once again, that same kind of issue here. We got minus a negative, so we're going to have to take negative 8x and write it as plus 36. And that's actually the final answer. Number 7, very similar, except for the x and the variable term and the constant term are switched in the parentheses, but that's no problem because we're still going to just do the same thing. 7 times 6 minus 7 times x. So what we end up with here is 7 times 6 times tables tell us that's 42, minus 7 times x is just 7x. And that's actually as far as we can take it. And then the last one here, distributing a negative 3, so negative 3 times x, negative 3 times 1. So we get negative 3 times x plus negative 3 times 1. So our answer here should be negative 3x plus negative 3. But once again, we have that little issue where we're adding a negative. So technically, to simplify it, we would write negative 3x minus 3. Okay, so now with all of that, they called that the warm-up section. So all these warm-ups in terms of like getting you used to combining like terms and using the distributive property, okay, we're going to take that and do the last types of questions, which is just simplifying expressions. And you're going to have all this different stuff happening in terms of distributive property and combining like terms, okay? So when you're simplifying expressions, an algebraic expression is in simplest form when it has no like terms and no parentheses, okay? So there's no more like terms we can combine, and we've taken care of the parentheses with the distributive property. So the steps you need to do to accomplish this are to first distribute. So number 1 is distribute, and then you combine like terms, okay? So distribute first, then combine like terms. So what does that mean? What does that look like? Well, let's look at number 1. Number 1 here, we've got 3 times in parentheses x minus 5 plus 8x plus 1. Well, it says distribute first. Well, you see the distributive property needs to be used right here where the parentheses are. So we're taking 3 and we're distributing it to the x and the 5, technically the negative 5. So in this case, we're going to get 3 times x. And notice what I'm going to do here to make it simpler and easy. I'm just going to go ahead and say that's 3 times x. That's going to be 3x minus 3 times 5. I know that's 15 plus 8x plus 1. And notice what I don't distribute just drops straight down. So it's still plus 8x plus 1. Okay. And now we're at a part where this is just like we did in the last section where we combine like terms. So I can combine the 3x and the 8. So it's 3x plus 8 gives me 11x. And then technically I've got a negative 15 plus 1 is going to give me a negative 14. So technically the answer here is 11x minus 14. And once again, this goes back to, if you need to, like I said, no problem with you taking it from here and writing it as a sum. And then combining all the terms. So 3x plus 8, or 3 plus 8 gives me 11x, plus negative 15 plus 1 gives me the negative 14. And then we got to go the one extra step of 11x minus 14. But I am going to start going through and trying to do these a little quicker, okay? For one, to save us time on the video so you don't have to sit here and watch a very long video. But at the same time, going through and once again, making it seem a little easier for you, because once again, you can go through here and speed it up really quickly once you do a lot of practicing, okay? So case in point, number 2, we're going to take the 5 and we're going to distribute it to the n and to the 6. Once again, we distribute first. So that tells us we've got 5 times n is 5n plus 5 times 6, which is 30. And now we can combine like terms. Well, there's no other variable terms for the n, so the 5n is going to stay. And then we're adding 30, then taking away 21. So 30 minus 21 gives us a positive 9. So our answer here is 5n plus 9. Okay, so going on, same kind of thing here. We're going to distribute the negative 7 to both of those terms. That's the only place where we see distributing. So we're going to have negative 7w. And like I said, once you get better with this, you'll see this is negative times a positive, so that should be a negative, so minus 28 plus 2w minus 15. Like I said, as you get better, you're going to see negative 7 plus 2w. So negative 7 plus 2 is going to give me negative 5w. So negative 28 plus negative 15, that's actually going to give me a negative 43. So minus 28 then minus 15 is the same thing as minusing 43. But like I said, and just so we can be clear on this, if you have trouble with the negatives and dealing with the minuses and all that, as always, write it as a sum, and you can clearly see what you need to add together in the case of whether it's negative or positive. So you've got negative 7 plus 2, that's where we get the 5w, plus negative 28 plus negative 15 gives me negative 43. So once again, you do it this way, you got that one last little step where you have to write it as 5w minus 43. Technically, negative 5w minus 43. Okay. Number 12, same kind of, or number 4, same kind of thing. You're going to distribute the 12. So in this case, 12 times 4. Once again, times table's coming in. 12 times 4, you should know that that's 48. Minus 12 times k, so 12k. And then we still have the minus 9k. So same thing as last section. If you need to, write this all as a sum and bring it together. But there's no constant term, so the 48 is going to stay there, okay? And then what's going to be left over? Well, we're subtracting 12k, then we're subtracting 9k. So that's the same thing as subtracting 21k. But at the same time, if you broke this down and wrote it as a sum, that would be negative 12 plus negative 9, which is negative 21. So we get 48 minus 21k. Getting a little bit more difficult, a lot more, a few more terms here we got to deal with. But once again, we see the parentheses. We need to deal with those first. So distribute So we get 6 times r, which is 6r, minus 6 times 2, which is 12, minus, and I'm going to go ahead and put a 1 in front of that r, plus 26 minus 7r. Same kind of deal here. Add all the constant terms. In this case, I will go through just so everybody can see. I'm going to rewrite it as a sum. And then combine all the terms that I can. So with the r's, I can add 6, negative 1, negative 7. So when I do that, that gives me a negative 2. Okay, so negative 2. And then once again, all those had r's, so that has to have an r. And then we're going to add to it negative 12 plus 26. That is a 14. And that's actually the final answer. Okay, that's all there is to it. Just the big thing to be careful with is do know how to deal with your negatives. That's the hardest part with all of this. Okay, so in this case, we see the distributing that needs to happen here. So we got to distribute the negative 4. So negative 4 times 7 is negative 28 m minus, in this case, negative 4 minus 16 plus 22 m. Now, in this case, we've got the negative 28m. We got minus a negative, so I'm going to go ahead and write that as plus 4. And then once again, you see this subtraction here. If you know how to work around that, we're going to have negative 28m plus 22m. That gives me the negative 6m. Plus 4 minus 16, that's the same thing as actually subtracting 12. So negative 6m minus 12, but once again, like I said, just to show you that you can still do it this way, 28m plus 4 plus negative 16 plus 22m. Well, same kind of thing. Negative 28 plus 22 gives us negative 6m plus 4 plus negative 16 is going to be negative 12. And then we just got to do that extra last step of plus a negative, so it's going to be minus 12. Okay. So to continue on, we still have a few more of these, so like 8 more. But once again, as you get better with it and you practice with it, they go a lot quicker. So in this case, we see the parentheses here. We're going to distribute this 5. Now, one thing I do have to say, so let me restart this one back over, is what I would do in this case, if we've got the parentheses somewhere other than the front, I would go ahead and write this as a sum. So in this case, negative 13 plus 5 times y plus 2. And then I'm going to go ahead and call this plus negative 8. So that way I can clearly see what I'm going to be distributing. It's going to be more clear when we look at number 8. But in this case, we've got negative 13 plus, in this case, I am distributing 5 to the y and to the 2. So it's going to be plus 5y plus 10 plus negative 8. And then we just go through like we've always done before. Negative 13 plus 10 plus negative 8. Okay, so we can do that, or we can see that we have the variable term right here. That's the only variable term, so we can go ahead and put down 5y. And then what's negative 13 plus 10 plus negative 8? Well, that's going to be negative 11. So plus negative 11. So we end up with 5y minus 11. And that one's a little tricky, and as you get to where the distributive property happens in the middle, like I said, it is probably better for you to write it as a sum, so that way you can clearly see what am I distributing. Case in point, number 8. Here we've got 12x minus 2 times 9 minus x. Well, in this case, it looks like you're going to distribute the 2. Okay, and this is where a lot of people get mixed up on a question like this. If you distribute the 2, that's not really what we need to distribute. And how we know that is, let's write it as a sum. Plus negative 2 times 9 plus negative 1x. Okay, so I just put the 1 in front of the x there, so it's plus negative 1x. So now we can see, well, what are we doing? What are we actually distributing? We're distributing the whole thing negative 2. Okay, So we get 12x plus negative 2 times 9 is negative 18, plus negative 2 times negative 1 is a positive 2x. Okay, so that was the tricky part here. If you see, I guess the rule to follow here is if you see subtraction, kind of like when we did when we were looking at the terms, you see subtraction in front of a term, technically it makes that term negative. So what you need to actually do is distribute the negative 2 here. So negative 2 times 9, negative 18. Negative 2 times negative 1x gives you positive 2. So 12x plus 2x gives us 14x plus the negative 18. And then we have to do that little last little trick there. Plus a negative is the same thing as minus a positive. So 14x minus 18. All right, so we're in the home stretch here. So last 6. And this one, same kind of deal. Notice there's no number that's in front of the parentheses. There's no number right here. So technically, based on what we did in a few minutes ago, is put a 1 there. But then we have the same thing that we did in the last one. You maybe want to distribute the 1, but technically here, once again, if we write it as a sum, shows that we want to distribute a negative 1. Okay, so the negative 1 gets distributed. So what we end up with is 18 plus negative 1 times 7 is negative 7v plus negative 1 times 1 is negative 1. And then the same kind of thing. Negative 7v is the only constant or variable term here, so let's just go ahead and write that down. Plus, well, what's 18 plus negative 1? Well, that's 17. So negative 7v plus 17 is the same thing as what we had up here. But like I said, the key thing here, so I'll put little stars by this one, and I'll go back and put stars by this one because really got to pay attention. What are you distributing? In this case, we're distributing a negative 2. Here we're distributing a negative 1. You guessed it on number 10, we're going to distribute a negative 6. Okay, but to clearly see that, that's why I always suggest writing it as a sum. So negative 6 times p minus 4. And then once again, I would do it on the inside here too. So p minus 4 would become p plus negative 4. And then we have the plus 22. And it can get confusing with all the parentheses here, especially with all the negatives and things like that. But if you can follow the parentheses, it actually makes it super easy. So we still have the negative 2p plus negative 6p plus negative 6 times negative 4, which is positive 24, plus 22. And then once again from here, we do negative 2 plus negative 6 is negative 8p plus 24 plus 22 gives us 46. So negative 8p plus 46. And it all comes back to knowing I had to distribute a negative 6 here since it's minus 6 times p minus 4. Here, that's technically meaning that you're adding negative 6 times p plus negative 4. Okay. Number 11, you guessed it, we're going to distribute negative 9 since it's minus 9. So in this case, we've got 1 plus negative 9 times 2n plus 3 plus a negative 7n. So once again, we got to distribute this first. We see these parentheses here. We got to distribute the negative 9. Okay. So we get 1 plus negative 9 times 2 is negative 18n plus negative 9 times 3 is negative 27. And then we still have the plus negative 7n. So bringing it all together. Okay. Once again, you can, historically, you would do the variable terms first. So negative 18 plus negative 7 gives us negative 25n. Plus 1 plus negative 27 is negative 26. So the last little step here, if we do write it as a sum, is let's write it back as plus negative 26 is minus positive 26. All right, and last 3 here. So this one is a new one in terms of that you have to do double the distributing, but in this case we have a plus here. But like I said, it doesn't hurt. Let's go ahead and write this as a sum. So meaning this a minus 4 is going to become a plus negative 4. And this 9 minus a is going to become 9 plus negative 1a. So now when we distribute, we're going to distribute this 2 to the a and to the negative 4, then the 3 to the 9 and the negative 1a. So 2 times a is 2a, plus 2 times negative 4 is negative 8, plus 3 times 9 is 27, and 3 times negative 1a plus negative 3a. So what are we left with here? 2 plus negative 3 is negative 1a, plus negative 8 plus 27 gives us 19. And technically, to write this simplified, same kind of thing we had earlier, normally with an answer, you probably won't see the 1 there, so this would just be negative a plus 19. But if you gave me this as an answer, or if you have to type it in even on a test or something like that, that would most likely give you the right answer there, because once again, it is correct. It's just normally if it's a 1 in front of something, we usually just leave it. We get rid of it. And the last two here, okay? So these are the two that are the toughest here, okay? So number 13, once again, we see we have subtraction here. So in order to help us not get caught up with what should we distribute here, let's just write it as a sum. So let's do 8 times 2k plus negative 7 plus negative 4 times k plus 5. And now we can clearly see, well, we're going to distribute the 8 to the 2k and the negative 7. We're going to distribute the negative 4 to the k and to the 5. So doing all that, we get 16k, 8 times 2 is 16, plus 8 times 7 is 56. Positive times a negative is negative 56. Okay. Once again, knowing your times tables does come in handy there, but always double check yourself on a calculator if you need to. Plus negative 4 times k is negative 4k. Plus negative 4 times 5 is negative 20. And then we just add all our terms together here. So 16k plus negative 4k is going to give us 12k, plus negative 56 plus negative 20 is negative 76. And then we have that same kind of thing, and you see it happen over and over and over again, so it's the same thing here. We got adding a negative, so it's going to be 12k minus 76. It's the final simplified answer there. And then the last one, same kind of thing here. Let's write it as a sum. So in this case, we'll have 14y plus, once again, technically, there's no number in front of that set of parentheses. It's a 1, so it would be a negative 1 times y plus negative 2 plus 5, and the rest of it's pretty easy because it's all addition. 5 times y plus 9. So once again, we see we're distributing negative 1 here and here. We're distributing the 5 here and here. So all comes together, 14y plus negative 1y plus negative 1 times negative 2 is 2, plus 5 times y is 5y, plus 5 times 9 is 45. So once again, just add all our like terms together here. 14 plus negative 1 plus 5. Okay, that's going to give us 18, and then y. And then 2 plus 45 gives us a positive 47, so plus 47. That's actually it. Okay. Now, as far as the homework goes, 20 questions. First 8 of them do just deal with the distributive property, so just reviewing and knowing how to do the distributive property. And then numbers 9 through 20 work exactly like all the questions we just looked at. So the last 14 questions we've done, or I guess technically last, let's see. Yeah, last 14 questions we've done. So go back, review, look at this. And like I said, the strongest thing that I can say for you is. So this is what you want to put down in that last little summary spot there. It says summary. Biggest thing I can tell you and biggest hint is to write as a sum. Okay. Once again, that will clearly tell you, okay. So this is what we'll say. So let me just do it like this. In summary, write as a sum when in doubt. Okay. And you should understand what it means to write as a sum, because I've done it pretty much on every example there. Okay. But if you still have trouble with thinking about what it means to write as a sum, please do let me know. Okay. Because that's really one key and trick that you can use to actually help make these types of questions so much easier for yourself. Okay. Now, one of the things we will be doing later is we're going to be taking things like this and we're going to be using them to solve equations. Well, if you're not able to simplify the expressions down, it's going to make you the process of you solving these equations pretty hard. Okay, so that's why this is so important. We need to know how to simplify expressions so that way when we do get into the instances where we need to solve equations or inequalities or graph equations, graph functions, it's a lot easier to graph something that looks like 18y plus 47 than it is to graph something that looks like 14y minus, in parentheses, y minus 2, close parentheses, plus 5, parentheses, y plus 9, parentheses. Okay? So, once again, that's the whole point in this, is to make something that's so complicated. This is really complicated. Get it down into something that's a little more manageable and so easier to deal with, especially when it comes to solving equations, as you'll see here in the next little bit. Okay. So once again, in summary, write as a sum, and then that should clearly show you what you need to add together in terms of coefficients and constant terms, and then also show you what you need to distribute in some of those examples, like number 14, number 13, number 11, okay, number 9, number 10, where you have this minus a number, then you're multiplying, okay? So like I said, if you write it as a sum, that leaves no doubt as to what you need to distribute and what you need to add together. So as always, thank you for watching, and if you do have any questions on the homework or any of the examples that I've done for you here, please let me know. Thank you.